in this video, we will be looking at linear quadratic system applications. So just a reminder, a linear quadratic system is made up of a line and a parabola, and the solution is the point of intersection, which can be found using substitution. You can also figure out the number of solutions or the number of points of intersection by using the discriminant, which is that b squared minus 4ac part that is under the square root in quadratic formula. So we're going to start off with a little bit of application related to the discriminant. So our first question states, how many points of intersection exist between the functions k of x and r of x? So this is just a knowledge question, just to refresh on what the discriminant is. And the discriminant is b squared minus 4ac. But we can only use that once we've done the substitution and turned our equation to standard form. So the first thing I want to do is set my two equations equal to each other. So negative x plus 6 equals x squared plus 5x plus 6. And now I'm going to bring everything over to the other side. So the negative x and the positive 6, remembering to switch signs. So I have 0 equals x squared, and then 5x plus x will be 6x, and 6 subtract 6 will be 0. So that's it. So our a value is 1, our b value is 6, and our c value is just 0. So now I can take this information and put it into my discriminant formula. So 6 squared minus 4 times 1 times 0, that gives me 36. So because our discriminant is greater than 0, that means that we will have 2 points of intersection. Therefore, there are 2 points of intersection. All right, now let's do the application side. So for what values of k will the function f at x equals 3x squared plus 4x plus k have 1 0 or no zeros? So here we're not actually creating a system with a line. We just want to figure out the value of k so that we have 1 0 or none. So if we have 1 0 only, so one x-intercept, that means our discriminant must be equal to 0. If we don't want any x-intercepts, that means that our discriminant should be less than 0 because we can't square root a negative number. So I'm going to start off with 1 0. So I'm going to set up my discriminant. So b squared would mean 4 squared minus 4 times a, which is 3, times c, which is k in this scenario. And if I want one x-intercept, I'm going to set this discriminant expression equal to 0 because I know what my discriminant should be equal to. And now I'm just going to solve for k. So first thing, let's simplify. And now I'm going to bring the 16 over to the other side. It becomes negative, and then divide both sides by negative 12. And I'm going to simplify my fraction. So first of all, that double negative will become positive, and 16 over 12 reduces to 4 over 3. So if I want one x-intercept, k must be equal to 4/3, and that's the only way. But if I want no x-intercepts, I'm going to take this discriminant expression, and I'm just going to say, instead of equal 0, I'm going to say less than 0. So 4 squared minus 4 times 3 times k, and you could have written the simplified version of 16 minus 12k, and that has to be less than 0. So now I'm going to clean it up again. And in order for you to solve the inequality, it's the exact same like solving a linear equation. There's just one little tweak that I will tell you in a minute. So we're going to bring the 16 over to the other side. And now here's the tweak. Whenever you divide both sides by a negative number, you're going to have to switch the inequality signs. So when divide by negative, switch sign. So in this case, instead of less than, we're going to now put greater than, and then we'll reduce 16 over 12 again to 4 over 3. Now, you can also avoid this by making sure the coefficient of k is positive. So something else I could have done here is instead of bringing the 16 over, I'm going to bring the 12 over. So 16 is less than 12k. Divide both sides by 12 and you get 4/3 is less than k. So now if you read this, k is greater than 4/3, which is exactly what we got before. So you can treat it in either way, but just remember, if you do divide by a negative number, you have to switch the inequality sign. So let's try the next one. For what values of k will the function f at x equals 6x squared minus 3x plus k have 1 0 or 2 zeros? So once again, let's set up our discriminant. We know for 1 0, the discriminant should be equal to 0. So why don't you go ahead and pause the video, set up your discriminant, set it equal to 0, and solve for k, and then come back to check your work. So for your discriminant, we're going to have negative 3 squared minus 4 times 6 times k. And then if we clean it up, we have 9 minus 24k equals 0. And when you isolate for k and reduce, you get positive 3/8. Now for 2 zeros, we know that the discriminant has to be greater than 0. So why don't you go ahead, pause the video, try it out, and see what happens. And again, be very careful with that inequality sign. Okay, so once you've simplified your discriminant, it's going to be that 9 minus 24k, but it's going to be greater than 0. If we bring the 9 over, it will be negative 9. And because we are dividing by a negative number, I am going to switch the greater than sign to less than. And then again, it reduces to 3/8. So k should be less than 3/8 to have 2 zeros. If it's greater than 3/8, then we would have no zeros. Okay, now let's go to some word problems related to linear systems. So, a car is traveling on the highway at a constant speed of 24 meters per second. A police car is parked on the side of the road as the car passes it. The instant that the car passes the police car accelerates from rest at a rate of 2.1 meters per second squared in pursuit of the car. If the equations of motion representing the car and the police car are c at t and p at t respectively, when and where will the police car catch the speeder? So really, the first few sentences were just a backstory. What we really care about here is that the car equation can be represented by 24t, so it's a linear equation because it's going at a constant speed. And the police car, because it is accelerating, it is represented by a quadratic equation. Now I am just going to create a little sketch because it's nice to have a visual. And we have time on the x-axis, and then we have distance on the y-axis. So we know that for our car, the equation is 24t. So it's just a line. I will label this c at t. And the police car, it's a parabola. Its y-intercept is also 0. So it might look something like this. So our goal is to find the point of intersection right over here. So that means it's the second point of intersection because the first point of intersection visually we can see is at the origin because they both have a y-intercept of 0. So now that we have the visual and we see what our goal is, let's do the algebra. And the algebra is the same as before. So I have two equations here. They're both equal to that distance. So I'm going to set them equal to each other. 24t is equal to 1.05 t squared. So it's quadratic, so I'm going to bring everything over to one side. So 1.05 t squared minus 24t. And now I am going to factor this. I'm not going to bother with quadratic formula because I can clearly see I have a common factor of t. And this should make sense because I do want one of my solutions to be 0. So when I branch out, t equals 0. And then when I do my other branch, I'm just going to set my bracket equal to 0, bring the 24 over, and then divide both sides by 1.05. And when I do that, I get approximately 22.9. So that means in 22.9 seconds, the police car will catch the speeder, but we also need to know where it is caught. So you can plug it into C at T or P at T. I'm just going to plug it into C at T because the line is always easier. So 24 times 22.9, and we get approximately 548.6. So the time was in seconds and the distance was in meters. So now, because it is a word problem, we do need a therefore statement. Therefore, the police catches the speeder after 22.9 seconds and 548.6 meters away. There we are. Let's try the next one. All right. A truck travels at a constant speed of 28 meters per second in the fast lane of a 2-lane highway. It approaches a stationary stopped car at the side of the road. When the truck is still 120 meters behind the car pulls out into the slow lane with an acceleration of 2.6 meters per second squared. If the equation of motion for the truck and the car at r t at t equals 28t and c at t equals 1.3 t squared plus 120, determine the following. Determine when the truck and car will meet and interpret the physical meaning of these meeting times. All right, so first thing, I do care about the equation. So the truck equation is linear because they are going at a constant speed. And then the car is accelerating, so it is quadratic. And because the truck is 120 meters behind the car has a different y-intercept. So I'm going to start off with a nice little sketch just to represent the situation, and that will help me with B. So I have time and I have distance. My truck is linear, so I'll draw it like this and label it T at T. And then the car has a y-intercept of 120. And it is quadratic, so it might look something like this. So we might actually have 2 points of intersection that we are looking for. All right, so let's go ahead and just do the algebra, solve for our points of intersection, and then we'll interpret their meaning. So first thing, let's set our two equations equal to each other. And now I want you to go ahead and pause the video, bring everything to one side, solve for your 2 times and your 2 distances, and then come back to check your work. And just a little hint, you might have to do quadratic formula here because, well, the numbers are quite large and annoying to deal with by factoring. So it's probably not factorable. So go ahead, pause the video, and then come back. All right, so we bring the 28t over, and be very careful that you have your standard form in proper order. So that negative 28t has to be in the middle so that we have t squared t constant. Then when you do your quadratic formula, make sure that negative 28 is in brackets because when you raise it to the power of 2, it will be a positive number. So hopefully you got the square root of 160. If you got something else, it's probably because of the brackets. And then you should have 15.6 and 5.9 for your times. It didn't ask for the distance, but I just showed it in case it did. So I have my 2 distances where they meet. But in my therefore statement, I just stated, therefore the car and truck meet at 5.9 and 15.6 seconds. Now, in terms of their meaning, there's 2 things. So the first one here at 5.9 seconds, that is when the truck which is here, passes the car. So after 5.9 seconds, the truck passes the car. But then as it continues, for our second point of intersection at 15.6 seconds, now the car that's behind the truck passes the truck. So that's the two meanings. So at 5.9 seconds, the truck passes the car because you can see it overturns it, and at 15.6 seconds, the car takes the lead and passes the truck. All right. One brisk winter morning, you're running a bit late for the bus, but you figure that due to the weather, the bus is also running late. Much to your surprise, when you turn the corner to the bus stop, you see the bus pulling away from the bus shelter that is 50 meters directly in front of you at a rate of 0.8 meters per second squared. Worried that you'll miss the bus, you start to run after it at a constant speed of 5 meters per second. If the equations of motion for you and the bus are y at t equals 5t, so you're linear because you're running at a constant speed, and b at t equals 0.4t squared plus 50, determine whether or not you'll be able to catch the bus and make it to school for a wonderful math class. Now notice, the question is not asking you when you'll catch up to the bus or at what distance you'll catch up to the bus. It is asking you whether or not you'll be able to, which is really just asking you, is there a point of intersection? Because if there is a point of intersection, then you do catch up to the bus. If there is no point of intersection, you miss it and you don't get to math class. So that means we're just going to use the discriminant because it's a waste of time to fully try to solve this. So I will start off by setting my equations equal to each other. And I'll bring that 5t over. And I'll put it in its proper place in standard form. And now I'll do my discriminant. Now for this type of question, I might have added at the end, figure this out without solving the equation. And that just means figure this out without doing the quadratic formula fully. You can still set your equations equal to each other and do the discriminant. So b squared means negative 5 squared minus 4 times your a value times your c value. And when we simplify that, we are going to get negative 55. So that because the discriminant is less than 0, that means there's no point of intersection, which means you will not be able to catch the bus. So therefore, you won't catch the bus. And that's it. So if you read it carefully, you can really save yourself some time by just using the discriminant where applicable. And let's try our last one. The revenue in thousands of a new hoodie company can be represented by the function r of x. The cost in thousands incurred by the company can be represented by the function c of x. In both functions, x represents the number of hoodies in thousands. How many hoodies need to be sold to break even? So break even means that the profit is equal to 0, which means you're not losing money and you're not making money. So revenue is what's coming in, and c of x is the cost for you. So if we just set our revenue and our cost equal to each other, we're figuring out when revenue and cost are the same, which means your profit would be 0 because you're not making or losing money. So let's go ahead and do that. Negative 20x squared plus 80x equals 120 minus 20x. And now we can bring everything over to one side and solve for this to see how many hoodies you need to sell to break even. So why don't you go ahead and pause the video, finish this off, write your therefore statement, then come back to check your work. All right, so when you bring everything over to one side, you have negative 20x squared plus 100x minus 120, or if you brought everything to the right, then the signs would just be different. I chose to factor out the negative 20, and then I had a nice simple trinomial, so I didn't do quadratic formula, but if you did, that's totally fine. You should still get positive 3 and 2. Now be careful here. This does not mean you have to sell 2 or 3 hoodies. That doesn't really make sense, not very realistic. If you go back to your scenario, you should have read that x represents the number of hoodies in thousands, which means this 2 and 3, we have to multiply it by 1,000 to actually get our answer. So therefore, 2,000 or 3,000 hoodies need to be sold to break even. Now, Just in terms of wording of this question, if the question had said, can this company break even? Then you wouldn't actually have to solve and you could use the discriminant. So be very careful in the wording to see if you actually have to solve for a point of intersection or if the question is asking you if it's just possible for the scenario to happen and for the intersection to occur. And that's it for linear and quadratic system applications.